Hey guys, Zulk here, back on my bullshit. And normally I would say if my voice sounds weird or if I sound tired, I would explain why, but look down to the bottom right corner of the screen. Yeah, it's 2:08 a.m. right now, so I think that is more than enough explanation of why I'm not as energetic as I usually am. But anyway, I thought it might be fun, I guess, to learn some C programming this late at night. And also another reason I'm feeling a lot tired right now is because it's been really hot today and I am sweating and like I I don't know how to finish that sentence. I was gonna cuss, but I don't know. But yeah, I am sweating a lot because of how hot it is. I think it's like close to 40 degrees today. And when I say 40 degrees, I mean it in Celsius, not Fahrenheit. So yeah, 40 degrees Celsius, which is like almost halfway to boiling point. So yeah, it's hot. But anyway, I am gonna read about inline functions. I've noticed that a lot of times when I am more tired than normal, I make better videos because I tend to ramble a lot. And in my opinion, in the videos where I ramble more are the ones that are usually better than my normal videos. But I have no idea how well that will translate to actually learning C++. It works well for video games, not sure about this. But I guess we won't find out until we try. Now will we? So let's get into it. Inline functions. Oh, right. In my tiredness, I forgot to mention this. I need to say this disclaimer. uh, because I don't want you to waste your guys' time. If you clicked on this video or any video in this series because you need to learn C++ and you need to learn how to do one or two things in C++, this is not the video nor the series for you. This is not your usual tutorial where someone who knows what they're doing goes through and teaches you an efficient way to do whatever it is you're trying to learn how to do. Instead, this is someone who has coding experience, who knows how to code, learning a new programming language. I know how to program in C and Python, and but C++ is not something I've actually practiced before. So I'm trying to teach myself how to do stuff in C++ using this book. So you may learn how to code if you follow this series, but no promises. And I can say that you won't learn how to program shit in C++ in a fast and efficient manner. So if you really need C++ for a project or something, this is not the series for you. Go find a different tutorial on YouTube, and whatever it is you need C++ for, I wish you good luck on that. Hope it goes well for you. With the disclaimer out of the way, let's get back into inline functions. As always, I'm not going to read every single line in the book. I am just going to read out the parts which I think is interesting or important. I am reading the whole book, but quietly, only reading aloud the parts that I find important, interesting, I guess. In C++, it is possible to define functions that are not actually called but rather are expanded in line at the point of each call. This is much the same way that a C-like parameterized macro works. What? It is possible to define functions that are not actually called but rather are expanded in line at the point of each call. The advantage of inline functions is that they have no overhead associated with the function call and return mechanism. This means that inline functions can be executed much faster than normal functions. The disadvantage of inline functions is that they are too large and called is that if they are too large and called too often, your program grows larger. For this reason, in general, only short functions are declared. And uh, as inline functions, okay, only short functions are declared as inline functions. To declare an inline function, simply precede the function's definition with inline specifier. For example, this short program. I actually want to do this. Wait, hold on. An inline function must be defined before it is first called. If it isn't, the compiler has no way to know that it is supposed to be expanded in line. The advantage of using inline rather than parameterized macros is twofold. First, it provides a more structured way to expand short functions in line. For example, when you create a parameterized macro, it is easy to forget that extra parentheses are often needed to ensure proper inline expansion in every case. Using inline functions prevents such problems. Second, an inline function might be able to be optimized more thoroughly by the compiler than a macro expansion. In any event, C programmers virtually never use parameterized macros, instead relying on inline to avoid overhead of a function call associated with a short function. It is important to understand that the inline specifier is a request, not a command, to the compiler. If for various reasons the compiler is unable to fulfill the request, the function is compiled as a normal function and the inline request is ignored. Depending upon your compiler, several restrictions to inline functions may apply. For example, some compilers will not But inline a function if it contains a static variable, a loop statement, a switch, or a goto, or if the function is recursive. You should check your compiler's user manual for specific restrictions to inline functions that might affect you. Any type of function can be inline, including functions that are members of classes. I am actually going to type out and run the second example in this book because I think it's kind of interesting. I am wondering though if inline is an request and it just defaults into normal function definitions if the request fails for whatever reason, why shouldn't I just inline everything? Because then when it can't inline, then it's just gonna act as a normal function. And if it can inline, then that just makes the code more efficient, right? I am probably missing something here. Anyway, let's do this. Uh, I need a paperweight. I need to use something as a paperweight. So I have this box which I used to keep my watch in. It's a cheap digital plastic watch. I'll just use that as a paperweight because the pages of my book were flying everywhere. I'm actually going to combine two examples together for this one because I want to use classes more just because I can. Hold on. There, much better. This is just going to cause some kind of a problem, I think. If I try this, this is going to cause a problem. Whatever, let's try it anyway. Oops, that's the wrong thing. So, by the way, I haven't used I haven't used a line operator like this in a while, but I think I remember what it does. So over here, what I'm basically doing with operators is asking, is A smaller than B? Question mark. Or if yes, then return A. If no, return B. So that's what this is doing here, if I remember correctly. And the logic here is that the mini function is just going to return whatever is minimum of two given numbers. So it's saying, is number A smaller than number B? Okay. If A is smaller than B, then return A, which is the smallest number. And if A is not smaller than B, then that means B is smaller than A, so return B. Of course, if I give two numbers, it's still going to return B, but whatever, it doesn't matter. I can probably fix it by using something like this, but it's fine. It's whatever, it's fine. Let's try overloading this. The books pages are still flying all over the place, even with. I'm gonna need to put paperweights here. There, I used my phone and my watch box. I guess you can call it that. But why am I trying to do? I really hope this works. Probably add more space. I kind of forgot what the difference between long and double is. I'll have to check that at some point. Whoa, don't need the semicolon there, friend. And that is the whole class definition. Now let's do int main. Y ob1. Okay. Now this should work. ob1 dot mini, let's see, -10 and 10 backslash n. So this should return 10. Oh no, wait, it's finding the smallest one, so it should return -10. 10.01, not minus, I just want normal 10.01 here. and 100.002. So it should return 10.01 again. Slash n. I forgot the semicolons, which would have been really bad. Why did I say OB2 here? It should be OB1. And lastly, OB1 dot mini, and then I have minus 10L and 12L. This one I don't know what this means. I'll be honest, I just copied this line wholesale from the book. Well, no, not exactly. The book didn't use mini as part of a class. That's something I did, because why the fuck not? I don't think I need this comma here. Slash n. Alright, let's hope this works. Oh, and I forgot, return 0. Also forgot, void. Let's hope this works. Line 21. Oh. Oh. I somehow missed that. Minus 10. They dropped the L and gave me minus 10, which is right. I did both long by accident. This one should be double, not long. So I do have to wonder, why did this not show the full one? Oh, it worked that time. I guess it was because it was conflicting with these ones, because they were virtually identical, I guess. So it worked that time. Double still dropped the L. I need to research what the difference between long and double is. But yeah. I was in my tired brain, I randomly was about to say the outro, even though it's only been like 23 minutes, and I definitely don't want to end this video right now. I do want to continue on. So that's inlining. And next we have automatic inlining, which I guess is related to this. And wow, that's the last topic in chapter 2. A closer look at classes, chapter 3. I will save that for the next episode. Not the automatic inlining part, the chapter 3 part. Because I feel like I need to study the automatic inlining right now, because it seems related to the topic I just went through. And because it's getting late and I'm also getting tired, I will save chapter 3 topics for the next episode. For now though, let's get into automatic inlining. If a member function's definition is short enough, the definition can be included inside the class declaration. Doing so causes the function to automatically become an inline function if possible. When a function is defined within a class declaration, the inline keyword is no longer necessary. However, it is not an error to use it in this situation. What? Hang on. I need to check this. So you may have seen me get quiet. That's because I was reading it silently, and after reading the text, I had a revelation that left me speechless and forgot to make me and left me speechless and made me forget that I was supposed to read interesting lines. Let me read this a small part of the topic word for word. If a member function's definition is short enough, the definition can be included inside the class declaration. Doing so causes the function to automatically become an inline function, if possible. When a function is defined within a class declaration, the inline keyword is no longer necessary. However, it is not an error to use it in this situation. For example, the divisible blah blah blah. This is talking about an example which I'm not going to read. Let me explain to you what this actually means using an example. Let's see if I already did this somewhere before. No, I'm just going to modify this code to show you a thing. Actually, no, I want to do it on the integer one because I don't know what the double does. Remove the inline. This is not an inline function. I don't want it to be an inline function because I want to show you guys something. Revelation. If I wonder how many people shouted at me to their computer screen when I was doing this in the who know what C++ is, how to who are masters of C++ and have seen me write classes in the previous episodes, but hang on, I'm getting ahead of myself. Still works. Okay, so let me explain what just happened. See, ever since I learned how to write classes in C++ like a few episodes back, I've been using functions like this. I've been writing functions like this. Remove the inline. Yeah, I've been writing functions like this. I've been defining them inside the class themselves. When the book first talked about how to define functions inside classes, well, define class functions, they used this format in the examples. Okay? But I never really used this because it seemed kind of complicated to me and seemed messy. Like I was having trouble. I felt like I would be having trouble keeping track of what function is part of what if I did it like this. And I just felt more comfortable writing functions like this, just defining them inside the classes themselves. That's just I was doing that because that's how I felt more comfortable writing functions. Apparently, I've been using inline functions this whole time without realizing it. Because when you do shit like this, even if you don't write the inline function, in C++, when you do shit like this, where you define a function inside a class, it is automatically considered to be an inline function. when you do shit like this. This is an inline function. This you don't have to write inline. You don't have to use the inline specifier, but this automatically gets it's used as an inline function when you do it in C++. I have not been doing that. I have been defining all the functions inside classes because that just was more comfortable to me. That just felt more comfortable to write functions for me. But yeah, apparently when I did that, I accidentally made them into inline functions, except when I violated some kind of restriction, compiler restriction on inline functions. I don't know how to feel about that. So basically, every single one of my functions was an inline function. Is that good? Is that bad? I have no idea. What do I do with this information? I have no idea. But fuck, I'm just gonna keep doing this shit until it causes an actual problem that I can fix. I'm gonna keep doing this shit. Again, I wonder how many actual master programmers who know C++ in and out have been screaming at me while they watch me use inline functions for everything when I really didn't mean to do that. But here you have it. I've been using inline functions the whole time. Let's just move on to chess.